Alright, we're going to be looking at differentiation, but this time we're going to be looking at differentiation of some trig functions. So let's take a simple one here, like f of x is equal to sine x. So these are going to be ones that you're just going to need to memorize. Right? So you need to memorize that the derivative of sine x, if we're asked to find f prime of x, the derivative of sine x is cosine x. Alright, so we need to memorize that the derivative of sine x is cosine x. What about if I were to write f of x is equal to cosine x, and we want to take the derivative of cosine x. So we want to find f prime of x here. The derivative of cosine x is negative sine x. So remember, the derivative of sine x was cosine x, but this time when you take the derivative of cosine x, you throw a negative out in front. So you have got to memorize those. Got to memorize them. What if we were given k of x is equal to tan x, and we want to find k prime of x? Well, if you don't have this memorized, then what you could do is you could turn this into sines and cosines. So we got to remember what tan x is equal to. It's sine x over cosine x. So we've converted tan x into sines and cosines, and we know that that's sine over cosine. So now we can take the derivative, since we've now memorized what the derivative of sine x is and cosine x. Okay, in the previous section we went over the quotient rule, and so once again we're going to have to use the quotient rule here. So we're going to take the derivative of the numerator, and the derivative of sine is definitely not that. Okay, the derivative of sine x is cosine x times the denominator, which is cosine x, minus the numerator, which is sine x, times the derivative of the denominator, and I'm going to put a parenthesis here because we have to use this negative, and it's negative sine x. And remember that it's all over the denominator squared. Now what we want to do is rewrite this stuff. So we have k prime of x is equal to cosine squared x. We have a minus here and a minus, or we have a minus here and a negative inside here. That's going to make that a plus sine squared x, and it's all over cosine squared x. Now one of our trig identities is that we know that cosine squared x plus sine squared x is 1. So you're going to have to be up on your trig in this class. Now we can rewrite cosine squared x. If we take this to the top, it will become secant squared x. That would be our k prime of x. So what you need to do is memorize the derivative of tan x, that's secant squared x, because it's going to save you a whole lot of time. Right? We want to definitely memorize that. Alright, we're taking derivatives and working some trigonometric functions. We need to make that a little darker. Okay, we got f of x is equal to secant x. So in some previous problems I said, listen, we need to memorize some of this stuff because it's going to make it really difficult if we're trying to work a problem on the test. And we got to go through all these steps. But what I'm doing here is just showing you that if you happen to forget, all you need to remember is sine and cosine, taking the derivatives of sine and cosine. So secant x can be rewritten as cosine x. Now what I'm going to do here is I'm going to use the quotient rule, okay, and just because. So we take the derivative of the numerator, which is 0, times the denominator, minus the numerator times the derivative of the denominator, and the derivative of cosine x is negative sine x. And it's all over cosine squared x. So this is our f prime of x now. So let's clean this up. And we're left with sine x over cosine squared x. And this is our f prime of x. Alright, and I'm going to rewrite this. This is sine x over cosine x times 1 over cosine x sine x over cosine x is tan x, and 1 over cosine x can be rewritten as secant x. So that is f prime of x is equal to tan x times secant x. Alright, let's work another one. We have y is equal to sine and then cosine x. So in this particular one here, we're going to take the derivative of sine x, which is cosine, and then we're going to take the derivative of cosine x and bring it out, and that's going to end up being negative sine x. So this is our y prime here. So we can just take this negative and bring it out front, and I'm just rewriting everything here. We have cosine of cosine x times sine x, and that is y prime. Alright. Alright, in this section here, we're still taking derivatives, or doing differentiation. And of course, if you're seeing this somewhere else, remember, this is my stuff. It's copyright protected, and this is my YouTube channel here. That's heavy coin. Okay, we are going to be taking derivatives this time of exponential functions, and let's just start with let's just start with this. We have s of x is equal to e to the 2x. And we're going to take the derivative of this. Now how this works is we look up here in the exponent and we take the derivative of this up here. So the derivative of 2x is just 2, and then we just rewrite the whole thing. and I'm going to say this is s prime of x. So that's pretty easy, right? Alright, let's look at one that's a little bit more difficult. I'm going to call it y is equal to e, and up here we're going to have x squared plus 1. So we take the derivative of the exponent, so the derivative of x squared plus 1 is 2x times, and then we just rewrite the whole thing. And of course I'm going to say y prime. Okay, moving right along. I'm going to use, go back to some other notation here so you don't forget it. So this operator says, hey look, we need to take the derivative of what's in the brackets here. And let's see, we have x cubed plus 2x plus 1. Okay, and I'm going to go ahead and put a parentheses around that. Okay, so this notation says, look, we want to take the derivative of this with respect to x. Just another way of asking to find the derivative. So we take the derivative of the numerator, or the derivative of this exponent here. So the derivative of x cubed is 3x. That would be squared, and the derivative of 2x is 2. And the derivative of 1 is 0. So I'm going to go ahead and put a parentheses around this. And then we just rewrite the whole thing. E, right, raised to the x cubed plus 2x plus 1. Okay, so this, right, is equal to this here. So just another way of asking, hey look, let's find the derivative. Okay, moving right along. This time our function will be called h. So hopefully you're getting the hang of this. I know I am. Okay, so I'm going to take the 2, bring it out front, rewrite everything in parentheses. About left that negative off. Subtracting 1 from the exponent, so I'm not going to write it there. Just 1 there. And then we take the derivative of what's inside and chain it out, right? So the derivative of e to the negative t is going to be negative e to the negative t, right? Derivative of negative t is negative 1, bring it out front, plus, and the amazing thing is that the derivative of e to the t is just e to the t. It's an amazing thing. And of course this is h prime of t. Alright, moving right along. Let's see here. How about we have, let's name our function r. How's that? R of, we'll use some different letters this time. R of y. So we're going to have y plus 1 and e to the square root of y. Okay, so this looks like the product rule. We have 2 separate functions here, and so we're going to use product rule. But let's get this out of radical form up here and put this into exponential form, this piece right here. So that means that I'm going to rewrite this. You're probably saying, why you just didn't write it the first time like that? Well, because you probably see it like this also. Okay, so we're going to use the product rule. So r prime of y So I'm going to take the derivative of this y plus 1 first. So the derivative of y plus 1 is just 1. Right? Derivative of y is 1, derivative of 1 is 0, times e to the y raised to the half, boy, plus, and then I'm going to rewrite y plus 1 times, now I'm going to take the derivative of e raised to the y to the half. So that means I'm going to take the derivative of the exponent and bring it out front. So that means that, I'm going to do some side work over here. Y to the half. So we're asked to take the derivative of this. So that means that we're going to take the half out front and then subtract 1 from the exponents. That gives us a negative a half. Alright. So bringing the half out front times y to the negative a half, right, times, and then we're just rewriting this whole part here. E y to the half. Now let's try to clean this up a little bit. So we have r prime of y is equal to e, and I'm going to go ahead and put this back into radical form. How's that? Plus, I'm going to take this half and just bring it out front of everything here. We have y plus 1, and this is y raised to the negative a half, and we need to take that down into the denominator. Actually, you know what? I'm going to rewrite this one more time if I have time to do that. E and square root of y. But let me just go ahead and write this one more time. So r prime of y is equal to e square roots of y plus, now I'm going to leave the y plus 1 in the numerator, put a parentheses around it, e to the square root of y, and that's going to all be over 2 times, and this is going to be the square root of y, and I think that's as far as I'm going to go on that. We could get this all in one single fraction, but we're not going to. Okay, so good enough. Okay, in the previous problems we were working with e raised to the x, and there was something I didn't actually tell you. We took the derivative of this, and we took the derivative of the exponent, which was 1, and then we just rewrote everything, and then we were done. But what I didn't tell you is there's a more general way of doing this, because that works with this particular one here, and the e is like 2.71, yada yada yada. But what if this base were a different number, like 2? Well, the more general way to take the derivative here, you would take the base and you would say, okay, we're going to take the natural log of the base. But you got to understand that the natural log of e is 1, and that's the reason we didn't write it here, because this would just end up being a 1 every time. Now that that's said, let's look at a problem like this. If I have f of x is equal to, let's say 2 raised to the 3x, and we want to find f prime of x. So we want to find the derivative. Well, we do it just like we did earlier with our base of e, except we just do one more thing. So we take the derivative of the exponent, and the derivative of the exponent, the derivative of 3x is 3. We rewrite everything, Except this time we're going to out here we're going to write the natural log of the base. So the natural log of 2. And we're done. Okay? So let's work some more of these so you can get the hang of it. What if we had f of x is equal to 5x? 5 raised to the x. So we take the derivative of x, which is 1, we rewrite everything, and then we say, okay, we got to take the natural log of the base out here. So that would be the natural log of 5, and that's going to be our f prime of x. And of course you don't write a 1 here, right? We say 5 raised to the x times the natural log of 5. Easy enough. Let's say that we have y is equal to 10, and then raised, we have x minus 2. So we just do the same thing. We're going to find y prime. So we take the derivative of x minus 2, and the derivative of x minus 2 is 1. Rewriting times the natural log of 10. The natural log of 10. Alright, easy enough, and of course we don't write the 1, just write 10 raised to the x minus 2 times natural log of 10. Alright, let's see here. We're going to have f of x is equal to x squared plus 1 times 6 to the x squared plus 1 again, let's say. And we want to find the derivative. So we're going to have to use the product rule. So f prime of x is equal to, so we're going to take the derivative of this first function here, which is 2x, right, times, and then rewrite, plus, and then we're going to rewrite this first part. Then we take the derivative of the second part, so the derivative of x squared plus 1 is 2x, and then we just rewrite 6x squared plus 1, and then we want to clean all this up, and really the only thing we do is take this 2x and bring it out front. And if you want to factor, you can factor it also. All right. Okay. In the previous problems, we were working with e raised to the x, and there was something I didn't actually tell you. We took the derivative of this, and we took the derivative of the exponent, which was 1, and then we just rewrote everything, and then we were done. But what I didn't tell you is there's a more general way of doing this, because that works with this particular one here, and the e is like 2.71, yada yada yada. But what if this base were a different number, like 2? Well, the more general way to take the derivative here, you would take the base and you would say, okay, we're going to take the natural log of the base. But you got to understand that the natural log of e is 1, and that's the reason we didn't write it here, because this would just end up being a 1 every time. Now that that's said, let's look at a problem like this. If I have f of x is equal to, let's say 2 raised to the 3x, and we want to find f prime of x. So we want to find the derivative. Well, we do it just like we did earlier with our base of e, except we just do one more thing. So we take the derivative of the exponent, and the derivative of the exponent, the derivative of 3x is 3. We rewrite everything, Except this time we're going to out here we're going to write the natural log of the base. So the natural log of 2. And we're done. Okay? So let's work some more of these so you can get the hang of it. What if we had f of x is equal to 5x? 5 raised to the x. So we take the derivative of x, which is 1, we rewrite everything, and then we say, okay, we got to take the natural log of the base out here. So that would be the natural log of 5, and that's going to be our f prime of x. And of course you don't write a 1 here, right? We say 5 raised to the x times the natural log of 5. Easy enough. Let's say that we have y is equal to 10, and then raised, we have x minus 2. So we just do the same thing. We're going to find y prime. So we take the derivative of x minus 2, and the derivative of x minus 2 is 1. Rewriting times the natural log of 10. The natural log of 10. Alright, easy enough, and of course we don't write the 1, just write 10 raised to the x minus 2 times natural log of 10. Alright, let's see here. We're going to have f of x is equal to x squared plus 1 times 6 to the x squared plus 1 again, let's say. And we want to find the derivative. So we're going to have to use the product rule. So f prime of x is equal to, so we're going to take the derivative of this first function here, which is 2x, right, times, and then rewrite, plus, and then we're going to rewrite this first part. Then we take the derivative of the second part, so the derivative of x squared plus 1 is 2x, and then we just rewrite 6x squared plus 1, and then we want to clean all this up, and really the only thing we do is take this 2x and bring it out front. And if you want to factor, you can factor it also. Alright. Alright, this will be a challenging problem here. We got y is equal to x raised to the x. So this is probably a good problem on a test to ask. And we are going to want to find y prime. Okay, so we want to find the derivative. Alright, so this is how we're going to do this. We're going to treat, first I'm going to treat this x as though it's a constant. So pretend it's a number like the number 2, for example. So we would do this just like we'd do if this was an exponential function with, let's say, the number 2 is the base. So that means you take the derivative of x, and the derivative of x is 1. And then we just rewrite everything times, and then remember we take the natural log of the base. So in this case it would be the natural log of x. Alright. Plus, now what we're going to do is we're going to treat as though this up here now is the constant. So pretend, for example, this is the number 2 here. So this is x raised to the 2 power. Just pretend it's a 2 or a 4 or whatever you want to do. So remember, we take this number and we bring it out front, and we rewrite the base, and we subtract 1 from the exponent. So this becomes x to the minus 1. Easy enough. Okay, well, we're done. Except what we need to do now really is simplify this down. This here is going to actually simplify down. Now pretend this here is a 1. Well, we don't, we just don't write it, but there's a 1 here for the exponent. And since both of our bases are the same, what we can do is add our exponents together. So we have x raised to the x times the natural log of x plus, now if I add my exponents, this becomes 1 plus, well, you know what, I'll just do it like this. 1 plus x minus 1. We might have forgotten how to do that, so I better not skip that step. And 1 plus x minus 1. Okay, so we have 1 minus 1 is 0, so this just becomes x raised to the x. And of course, I guess I'll rewrite the rest of it here. The natural log of x is equal to y prime. So this is one that you may have never seen before. I've got some others up my sleeve. I think we'll do these again. Okay, so let's say that we, whoa, had something sneak in there. Alright, so let's say that we're asked, using some different notation here, but it's the same, we're asking the same question. In other words, find the derivative. So remember, so this is quiz time, okay? We're going to treat this like it's a number, like it's a 2 raised to the 3x, let's say. So we're going to take the derivative of 3x, which is 3, rewrite, times, and then we say the natural log of x, plus, now we're going to treat this like it's just a number up here. So that means you take the 3x and bring it out front. Where are we at? I better be looking at this one over here. Taking the 3x and bring it up out front, writing everything. And then remember, we have to subtract 1 from the exponent. Up here, subtract 1 from the exponent. Okay, and then of course we can simplify this thing down. I'm going to rewrite everything here. 3x to the 3x, 3 times x to the 3x, times the natural log of x plus, now this right here, okay, I'm going to write 3x, remember this is a 1 right here, okay, so this becomes, I'm trying to think of the best way to, so you don't get confused. I think I'm going to separate this guy here. Okay, so I can split this part here up as x raised to 3x times x to the negative 1. Now if we have an x here to the first power and an x to the negative 1, those guys are going to cancel out. Alright, and so we're just going to end up being left with, just rewriting everything again. Plus 3x, right, raised to the 3x there. Okay, and of course that's our derivative. Alright, well let's work some more of these. I like these. These are fun. Let's do it. Actually, I think I'll just work one more of these maybe. I don't know. Y is equal to 4, ooh, just getting ahead of myself there, x and 4 raised to the 4x squared. Alright, so we want to find y prime. So y prime is equal to, now remember, we're going to treat this like it's just a number down here, okay, like the number 3. So we take the derivative of the exponent, which is going to end up being 8x times, and then we just rewrite times the natural log of x, right, plus, now we're going to treat this like it's just a number. Okay, this is x raised to just some number, let's say 7 or something. Right, so we take it, we bring it out front, rewrite, except remember, if this is just a number up here like 7, we subtract 1 from it. So we have to subtract 1 from that. Okay, and then we can simplify this thing down. So I'll just rewrite 8. Now we have an x here to the first power, right? And we have an x, same base, but it's raised to the 4x squared. So we can add these exponents together. We can add these exponents. So this becomes x to the 4x squared plus 1 times the natural log of x plus, okay, so these bases are both the same, right? And we have a 2 here, so we can add this exponent to this exponent up here. So we have 4x, and so we have 2 and a minus 1 over here. If we were adding these together, let me just rewrite what I'm doing here. This would be 2 plus 4x squared minus 1. So 2 minus 1 is 1. So this just becomes 4x squared plus 1 up here in the exponent. And I think I'm just going to leave it right there. That's okay with you. Okay. I guess I'm going to work one more of these type of problems, and then we'll give it a quit on that and work on some absolute value, and then some log functions. Ooh, boy, how would you like to see this one on a test? Find the derivative of 1 plus x raised to the 1 over x. Well, I'll tell you right now, it's not that bad. If you've been following the last 3 problems, you should be able to get this one easily. So remember, we're going to treat this, what's down here in the base, we're going to treat this like it's a number. Actually, you know what? I think the first thing I'm going to do here is I'm going to rewrite this problem. So let me just rewrite it. 1 plus x. Now I'm going to rewrite this exponent up here as x to the negative 1, right? So if we take this x and take it into the numerator, right, the exponent becomes negative 1. Okay, now let's take the derivative. So treat this like it's a number. So we're going to take the derivative of x to the negative 1, okay, take the derivative of this, and that is, we're going to take the negative 1, bring it out front, right, and subtracting 1 from this, so this becomes x raised to the negative 2, and then we just rewrite everything, 1 plus x, and x to the negative 1. And then we take the natural log of this piece here. So the natural log of 1 plus x. Right? Nothing difficult about that. And now I have run out of room. So let me put a plus here. Okay, and continue it down below. Now we're going to treat this like it's just a number, like the number 5, and so we have treat this like it's just x. number 5. Okay, so we're going to take the derivative, or take our exponent and bring it out front. So this becomes x to the negative 1. Like if that were a 5, you'd bring it out front, you'd write a 5 here. Now I'm going to rewrite. And remember, we subtract 1 from the exponents. This becomes x to the negative 1 minus 1. Alright, then we do the chain rule, taking the derivative of what's in here and bringing it out. So the derivative of 1 plus x is just 1. Okay. Now, I've got a negative over here. And I think what I'm going to do here is I'm going to rewrite all this. Rewriting this part first. And we're going to have negative x to the negative 2, 1 plus x, and I'm going to go ahead and rewrite this as 1 over x, if that's okay with you, times the natural log of 1 plus x, plus, I think I can squeeze this in, x to the negative 1, and this up here, I guess I'll just rewrite as 1 plus x raised to the, just keep it like this, x to the negative 1 minus 1. Okay. I think I was able to squeeze all that in. Well, I'm going to leave it like that. We can rewrite this, this x to the negative 2. We can write x to the squared down here and write x down here and so forth, but I'm going to leave it just like this so you can kind of hopefully follow those steps. Alright, let's move on to some absolute value functions. Alright, we're going to be taking the derivative of an absolute value function. So here's something that we need to remember first before I even get started. This is the absolute value of x. And the absolute value of x is kind of like saying this, right? X squared and then square rooted. In other words, no matter what we plug into this right here, it's going to always be a positive number out. So if we plug a negative number in, like negative 5, we take the absolute value of it, we get positive 5. Okay, so this is a whole lot better writing it like this than it is like this right here. Alright, so this is how this works. Let's say we're asked to find, and I'm going to use this notation, no rhyme or reason, just to kind of keep you fresh, keep your mind fresh. We are asked to find the derivative of the absolute value of x. The absolute value of x. Now I'm going to rewrite this here as x squared, and getting it out of radical and putting it into exponential notation. Okay, this is raised to the half power. So basically, look at this. This is what we're taking the derivative of. Alright, so you take the power up here and you bring it out front. So I'm going to take this power and I'm going to bring it out front. And then I'm going to rewrite. Now remember what you do with this. You subtract 1 from the exponent. So this becomes a negative a half. And then we're going to take the derivative of the inside here and bring it out. So the derivative of x squared is 2x. And now what we're going to do is we're going to just simplify this thing down. So a half of 2 is 1. And this right here becomes just x on top, over, and then because it's a negative exponent, I can take this down into the bottom and make it a positive exponent. Of course, we can rewrite this as x over the square root of x squared. Okay. So the derivative of the absolute value of x is x over the square root of x squared. Let's look at another one. Okay, so we're going to take the absolute value of x squared minus 4. Now, in the last one, we've just put an x right here, and it was squared, and all of it raised to the half. But now we're substituting that x in for this x squared minus 4. So we're taking the derivative of this guy right here. That's all that we're doing. And that means that you're going to take the half and bring it out front. Whoa, that's a half, not a fourth. I don't know where I got that. X squared minus 4 squared, subtracting 1, so we get a negative a half, and then we're going to take the derivative of the inside. So that means we're going to take the derivative of, we're going to take this 2, rewrite, whoa, Nelly, and then we got to take the derivative again, so this becomes 2x. And then what we're going to do is just simplify it all down. So let's scroll up the screen a little bit, try to clean this mess. What a mess. Half of 2, that's going to go away. We're going to be left with a 2x in the numerator times x squared minus 4. And that's going to all be over. This is going to go down to the bottom. I'm going to go ahead and just say, look, let's make that a square root, okay? And then I'm going to put a parentheses. We have x squared minus 4 quantity squared. So there is the derivative. Man, what a mess. Alright, I guess this next section of videos is going to be over taking the derivative of log functions. So you want to definitely catch up on that.